We have an insane idea.
More like a crazy idea.
And we're not exactly sure how it's gonna work. So it's basically one half
with another half with a ball inside of it, and then when you close it,
it spins really, really nicely. I'm just gonna start with making the 3D model on Fusion, and then I can get ready to print it. Okay, so I'm just gonna start by creating a sketch on the top plane, 30 by 30 mil, using a center point rectangle. And then since I'm done with that sketch, I'm just gonna finish the sketch. Okay, so I'm just gonna go to the extrude tool on the top section. I'm gonna select this face and I'm gonna go -15 because it's gonna be a 30 mil cube. And then I'm gonna create a new body and press enter. Okay, so now I'm just gonna make the hemispherical indent. So I'm gonna go to the sphere tool and I'm gonna choose the top plane, and I'll use the center point for the part of the hemisphere. Then I'm going to choose 20.1 or 0.05, and then I'm going to make it cut, and then I'll be left with the hemispherical indent. It's going to be made 20.1 millimeters because the ball that we're going to have is 20 mils exactly, so it needs a bit of tolerance for it to actually fit in. Okay, so I've got the model of the build plate, and this is basically it, and it just spins really well, and it stays in place.
So after all that, we're in the workshop. We start with this blank. We're going to take off a bit of all surfaces to square it, and then we're going to cut it into 15mm slices.
What are we doing now?
Put the parallels in, so that I can rest the cube on it. Close the vise a little bit. Just make sure it's resting on it.
Okay.
There we go.
And now what we're gonna do?
We're gonna swap out the drill so we can drill through it.
Yep, this is what we're gonna put on it.
Yep.
We started off with a 29 by 29 block, which we then milled to make it perfectly square, and then cut a bit more to be 28.8 on both sides. Then with a 10mm drill bit, we drilled down 7mm to help guide the big drill. With the 20mm hemispherical cutter, we went down by a bit less than 10mm. Then we stopped and measured with a bearing ball to see how much we cut down by.
Go on, Professor Tiago, explain your work.
So basically, right, we have to do some maths first.
Yes, of course, of
So
course.
here we have the diameter of the drill bit.
20 mil.
20mm.
Yes.
So we're going to have to half that to get 10.
Yes, 20 over 2 equals 10, exactly.
Yep, and then we calculated, we measured it.
Yep.
The length of this side is 28.8, and the same for this one here.
It's a perfect square.
Exactly, precisely. We're just too good.
Exactly.
So what we do, we half this to get 14.4.
Yeah, because 28.8 over 2 is 14.4.
Precisely. So to get to the middle, what we're going to do, we're going to touch on with the drill bit.
It will actually be touching, it won't have a gap.
Yeah.
So we're going to touch it on, we're going to zero it.
Yeah, 0.
It will actually be touching, it won't have a gap. Go on.
So we're going to zero it. So then what we're going to have to do,
Perfectly zeroed, yep.
we're going to have to move it by 14.4.
Exactly,
Which is
because
half
that's
of
half
this.
the length.
Center of
Exactly.
the cube,
Yeah, that's what the center is.
And then
center.
10 from here.
Yeah, 10, because that's the radius,
That's the radius
of
of
the
the
drill
drill
bit.
bit.
So that move is exactly to the middle.
Exactly to the middle.
So we're going to do the same on this side. So we're going to tap on, zero it, and
Yep,
then move
zero
it
it.
down by how much?
24.4.
24.4.
Precisely.
Exactly. Because it's a perfect square.
Stop. .95.
Okay. Which is 30.42 mil. Professor Lil T, go on.
Got Professor T right here.
Alright, so you guys might be wondering, why are we putting the bearing ball inside of the machine?
The milling
ball?
machine.
Over there.
Exactly. So, what do we have right now?
A perfect cube, a very
there.
perfect cube, yeah.
Exactly. And we have cut.
A semi-hemisphere right
A
there.
semi-hemisphere.
It's a hemisphere. But alright, here we go.
Okay, go on.
There we go. You
So,
got it.
if I was just to bring out my measuring contraption, it looks like this.
Yes.
It's got a flat,
It's got a flat face.
yep,
Exactly.
flat face here.
Yep.
So if I bring it down into here, you can see
There's gonna be a gap
missing
that
a
it
gap.
can't measure.
there's no gap.
Yep.
And that would just mess it up because then the bearing would go into here and that wouldn't be any good.
Exactly.
Exactly.
So how do we fix that?
By putting a ball at the bottom.
Exactly.
Precisely.
To make up for that gap.
So the ball will be here. It'll touch the exact bottom here, which is what we need.
Yep.
Exactly.
And then we'll have
It's gonna make a
the
tangent.
measuring face onto here. So this will touch, obviously.
Yep.
My drawings and skills are
It's gonna make a tangent, so it's gonna be perfectly measured.
Exactly.
So from here, we do this. We measure the height of the ball.
And the height of the measuring tool.
And then you
up
add it.
to this surface here.
Yep. So then we add them together. X and Y, X plus Y, and then we get the measurement, which
Of
is
the total
this guy.
height.
Exactly. Unfortunately, though, it's imperial.
Yeah.
So what do?
It's in freedom units, so we have to convert it.
Exactly. So we're gonna go from imperial to metric.
Yep.
And it's done.
I ordered a package for ball bearings, and they came. They were supposed to be 304 stainless steel, but they were magnetic. And I did my research beforehand, and 304 isn't generally magnetic, so that's why I ordered these. This is going to be for a later prototype, but unfortunately they were. Luckily, it's not too much of an issue right now, but it might cause an issue a bit later on. So we finished boring out the centers of each of the half cube parts, and the problem is that the bearing balls are exactly 20 millimeters, and the drill bit that we used is also exactly 20 millimeters, so they don't fit inside each other. So what we need to do is we need to remove the chuck from the lathe, and we're going to install a 4-jaw chuck so that we can grip the cube properly. And then what we're going to do is we're going to get some abrasives, and we're going to sand down the inside. That way it's going to still be perfectly hemispherical, and it can hold the ball in correctly. So initially we're just changing it to a 4-jaw chuck, which was just a series of aligning the edge of the cutouts into a straight line and then removing it. And then after we did that, it was just a case of making sure that the cubes were perfectly centered so that they wasn't wobbling around too much, and it would be way easier to actually sand it down. We put a very slight polish on it though, because it didn't need to be perfect. This is just the first prototype, and trying to align it was an issue. We had to use quite a few packing pieces, digital height gauge, and then we started it several times just to see if it was actually functional. As you can see, this is not fully perfect yet. You can take the top off really well, and you can put it back on. It spins nicely and everything. But if you look closely, then you can see that it's not perfectly aligned. So we're gonna take a pass on the mill. We will just like get some soft jaws or something, put them in. While the ball's aligned, we'll just make sure that everything's flat. That way they're gonna have a perfect finish and basically a zero tolerance look. For the final part, we're just making it completely flush. So what we did was positioned it in the chuck, and we put the ball in the middle of the cube so that it would be perfectly aligned. And then we took several passes using the big cutter on the milling machine, and we used the same thing for the chamfers. And then that way it would be perfectly aligned, and it will be perfect cube and have hopefully even chamfers.
So the first prototype is done. It's here.
Make sure you subscribe to stay updated with the project.